Hi everyone, it's Dave here from Fine Line Joinery. So, for reasons I'll get into a little later, I no longer have this Delta line boring machine. If you're not familiar with the purpose of such a machine, it drills the series of holes you probably have inside some of your cabinets that allow you to move support pins up or down to set your shelf heights. Needless to say, in most cabinet projects, there are a lot of holes to drill. In this video, I'll show you how I set up my Longmill benchtop CNC to drill these without having to open my design software to create a new toolpath for every situation that may occur in a project. So, about 6 months ago, I downsized my shop from a 4,500 square foot industrial space back to the two-car garage where I started building custom cabinets some 20 plus years ago. My projects just kept getting bigger and bigger over the years, and I finally decided that I just didn't need that much stress in my life anymore. So I downsized and resolved to only take on more manageable jobs like bathrooms and small kitchens. The downsizing process required me to say adios to any single-purpose machines I had, and one of the first to go was my Delta line boring machine. Coincidentally, it was the first single-purpose machine I purchased when I started building cabinets in my garage. I had tried one of the drilling guides on the market, but knew pretty quickly that the Delta wouldn't take long to pay for itself. It does in about an hour what took me a day with the drilling guide. But still, no single-purpose machines had to be my new mantra. Therefore, what I needed was to figure out the most efficient way to create the Gcode to drill lots of holes in straight lines with my Longmill CNC. I mean, how hard could that be? All I needed was to learn how to read and write Gcode and a way to program something to do it for me based on some basic parameters. I thought an Excel spreadsheet would be ideal. I could use one spreadsheet to list my parameters, then write the Gcode to another using Visual Basic, Excel's built-in programming language. I'm far from being a proficient programmer, but I know enough to muddle my way through. What I ended up with is what I call my Parametric Line Boring Gcode Generator, or PLBGG for short. If you want to skip all the Gcode and programming stuff and see how the PLBGG works, you can use the bookmarks down in the description. And no, I won't hold that against you. Clearly, the first thing is learning to read and write Gcode. I created a sample project in VCarve with 2 columns of 5mm holes spaced 32mm apart, created the toolpath, and saved the Gcode file. So far, so good, right? Then I opened the file to look at the code. Okay, I don't understand any of that, but I think maybe I could. I see X's, Y's, and Z's, so that's good. And lots of G's, which obviously stands for Google it. The most straightforward tutorial I found was this one from How to Mechatronics, which covers the most common commands and simple explanations of how they work. I also found this handy Gerbil pocket reference, which is a much more comprehensive list. With these new tools tucked into my belt, I pasted the contents of the Gcode file onto an Excel sheet and proceeded to decode it. With that done, I looked through the Gcode to identify the parameters I would need and copied them to my parameters page. I'll also need the panel dimensions, just like when setting up the sample project in VCarve. Now, a more sane person might have called this good as far as a parameter input page. It would have been all too simple to just use column B here to type in my parameters and start figuring out my calculations from there. But I guess I'm just not that guy because I ended up with this. Yeah. So this is the main parameter input section where I can enter the basic hole info and panel dimensions. Reviewing my thought process from the years of using the old Delta machine, I knew I would need to specify the backsets from each edge. Those are the distances from front and back edges to each column of holes. I would also need to specify the start distance from the end of the panel and where to stop drilling the holes. Here I can choose whether to index the holes from the top or bottom of the cabinets. I generally use the bottom for base units and the top for uppers because that'll usually cause the shelves to all line up across a bank of cabinets. I decided to add the option of being able to drill more than 2 columns of holes for the rare case of needing a third column for extra deep shelves or when I know shelves will be heavily loaded. And lastly, because I want to zero the workspace once on a single alignment fence on the CNC bed, I need to know whether the panel being drilled is a right or left side. If I always place a front edge against the alignment fence, a right side will have its top end at 0 and a left side will have its bottom end there. So I'll need to calculate an adjustment for that. I have this section for machine settings. I know I'll need to tile panels that are longer than my machine's cutting capacity, so I can specify that here, as well as my Z clearances, spindle speed in case I upgrade to a spindle, and drilling plunge rate. And each of these dimension inputs has a button that toggles between metric and inches, so for convenience I can mix and match units at will. Up at the top of the form, I have a place for project and toolpath names that'll be useful for generating a toolpath summary page. Unable to procrastinate any longer, I finally fumbled my way through the programming and eventually ended up with this, which takes all the input info, performs some calculations, and spits out Gcode. By the way, if you've noticed how short I have my machine cutting length set, that's to keep the Gcode output short, to make it easier to proofread, and to make the actual testing on my machine faster and use up less material. This button runs my program and makes the magic happen. Bam! So, based on the panel length of 24 inches and the maximum machine cutting length of 9 inches, line boring this part would require 3 tiling operations. Listed are the Gcode sets for each of those. The first tile, 1 continuation tile, and the last tile. I designed this so that when more than 3 tiles are required, the continuation toolpaths will all be the same. For example, if this would have needed 4 tiles, the continuation tile would be labeled ×2 here instead of ×1. From here, I could copy each of the toolpaths into a text file, change the file extension to Gcode, and they would be machine ready. But why not automate that too? Back into programming mode, I worked out how to do just that, plus generate the toolpath summaries I mentioned earlier. All of that is triggered by this button. I now have these 3 tile components of Toolpath 01, which correspond with the matching name on my summary page. The project and toolpath names carried over from the parameter input form. Looks like it's time to put these Gcode files to the real test. I'll load the first tile toolpath into GCenter and give it a whirl. So far, so good. But let's break here for a second to talk about indexing these tiled toolpaths. I wrote my program with the intention of indexing everything after the first tile off of the center of the last hole drilled on the previous path. With that in mind, I designed this little indexing tool. These pins are 4.8 millimeters to fit into the 5 millimeter holes and spaced 32 millimeters apart. Similarly, this edge is 32 millimeters from the center of the last pin and will bump into the end of my alignment fence. My Excel program starts each successive tile from y equals 32 millimeters. So let's see how it works. Okay, for starters, if I made the block from a piece of clear plastic, it would be a lot easier to find the holes. I'll load the continuation tile toolpath, which in this case has only 2 rows of holes. Okay, it looks like it skipped a row of holes, but what happened is that I forgot to line up the end of my index block with the last hole drilled. Instead, I placed it with its pins in the last holes. I'll need to memorize this workflow. Well, that was better, except for trying to drill through that hold down. There, let's just pretend that didn't happen. All right, looking good. That was a right side panel. I also generated a set of left side tiling paths. Hopefully I'll end up with 2 parts that mirror each other. In case you've wondered why that continuation tile only has 2 rows of holes, that is by design. I distributed the holes among the tiles, always leaving the maximum number possible for the last tile. That assures that the panel being drilled always has full contact with the alignment fence. If the last tile only had a few rows of holes to drill, it could have very little contact and be more difficult to align properly. Yeah, I need to figure out a way to foolproof this workflow. So let's see if my left and right tool paths actually mirror each other. With the front edges facing each other, the rows should line up. And with one flipped around, they should be off. Success! Yay, Dave! So let's revisit this index tool. Apparently, milling 5mm pins cross-grain on a piece of oak may not yield the longest lasting jig. I did intend this as a prototype, but I had hoped it would last a little longer. I happen to have a lot of offcuts of this HDPE plastic, so I'm remaking my jig from a piece of that. This stuff is really tough, and for the most part cuts and mills like wood. While that was being milled, I had some more thoughts on how I might improve it further to avoid repeating that indexing mistake I kept making. Okay, so the mistake I made here when I had to cover up those holes with the blue tape and re-index this was that I placed these indexing pins in the last hole I had drilled, like so, and then it started drilling from the next location up here. I mean, yeah, I can just easily back this up a hole for my indexing, but it's a lot easier to remember if I just stick these pins in the last hole drilled. So I think I can solve that by notching this block out here so that the indexing point, which moves from this surface back to here, lines up with the center of that pin. And I also think this would be easier to index if I had some marks on the end here that align with the line of holes here, so I can more easily know where those pins will line up. I mean, yeah, ideally, if this were clear, that would be perfect, but I don't have a 3/4 inch thick piece of clear plastic handy, so I'm going with this. I think that's going to work great. There is one more workflow issue I want to improve on, though. That's the fact that I have to load a new toolpath into GSender for every tile. For a one-off project, that's not a big deal. But in production mode, it adds up to way too much time and more chances for me to screw up by loading the wrong file. Imagine having 8 identical parts that each required 3 tiles to drill. That would take 24 file loads to keep track of. If those 3 tiling paths were combined into one toolpath that paused in between tiles to allow for re-indexing of the part, loading the file once is all that would be needed to mill those 8 parts. So, back to my computer to upgrade the parametric line boring Gcode generator to PLBGG v2. And here you have it. It may look the same on the surface, but it's what's under the hood that matters. Generating the Gcode now identifies a part that will require tiling and offers the option of combining the tiles into a single toolpath. It seems like that's what I would always want, but I left the option just in case. And there's my single combined toolpath. By the way, I set this up to always save the Gcode file to the same folder that the Excel file is in. So in practice, I would have a project folder, a CNC subfolder within that, and a line boring subfolder within that one, with a copy of the Excel PLBGG file living there. And that's where my Gcode files will be created. I use an M8 command in my Gcode and an IoT relay to automatically turn on my router, but for some reason I had the IoT switched off. Oh, crud. I guess I lost my Z0 when I tried to ram that drill bit down through the wood without it running. Notice how I have the XZ gantry move back out of the way, giving me better access for indexing the part. Saves having to jog it back every time. I gotta say, I'm pretty pleased with how this is working. I think the upgraded indexing tool was a great improvement over the first one, and all in all, I think this will make a fine replacement for that Delta machine. If you're interested in the PLBGG Excel file, let me know in the comments. I'll post it somewhere and add a link to it here. But no guarantees, minimal tech support, and it's only been tested on Windows. Thanks for watching and happy CNCing. 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 Yeah.